Okay, welcome to this session. In this session, we are going to see the next category, that is the seventh category. Totally 9 categories, out of which we have completed the 6th category in the past two parts, that is part 1 and part 2, and this is part 3. Here we will be covering the two remaining categories, that is 7th one and 8th one, and the 9th one is conclusion. There is no need to have any task. Let's continue the session. Here the next category is Simscape and Simulink, that is feedback control. Here is the introduction, how we will be incorporating the feedback in the electromechanical system. Like that, they have given the overview of this category, and just click on next. Okay, this is the next category. Here they have mentioned the task 1. Basically they have given the outline of the Simulink. Here they have given the task that add an ideal rotational motion sensor. So you have to add ideal rotational motion sensor under foundation library. Once again, I clicked and I have included, and connect the sensor to the sensor so that it measures the rotational motion of the generator as a positive value. Here you have to connect, just bring this to downward, these two to downward. Just rotate R to R and C to C. You have to connect. If you have any doubt, you can use this hint, or you can use this C solution, where they have given the exact structure. Okay, how we have to connect. Like this we have to connect. I have already connected. And now coming to the task, we have to add PS to Simulink converter. Okay, that is PS to Simulink converter, which is available, and this has to be added, and that has to be connected to W. We have to connect, and this is the task, first task. Just submit, and next task. Here the next task is, here you have to replace the pipe block connected to the rotational mechanical converter block with the local restriction IL block. Okay, here is the block, that is pipe block. This is the pipe block connected to this rotational mechanical converter. Okay, here you can see the rotational mechanical converter is connected to this pipe block. Okay, just delete the pipe block. Now I have deleted. Instead of this, we have to include local restriction IL block from foundation library. This is the block. This has to be connected like this. Have to connect it like this fashion, and set a minimum restriction area. In this block, we have to set the minimum restriction area. This is here. Minimum restriction area is given as 1 e per minus 10. That has to be replaced with you have to replace it with the value of 0.05. 0.05 you have to replace meter squared. There is no need to change, and the maximum restriction value is around 1 meter squared. You have to set the value. Okay, this is about the settings. Now you have to add a Simulink to PS converter. Okay, Simulink to PS converter we have to add. Here you have to add Simulink to PS converter. You have to rotate using Ctrl plus R. Now you can connect to the physical signal port, that is CR. With this you have to connect. Port. To connect it like this. No need to rotate. Have to connect it like this. And submit. And task is over. And the next task. Here we have to add constant block. And then sum block you have to add. Both we have added, constant as well as sum. With this here, constant block and then sum block. You can connect it. And then discrete PED controller you have to add. This you have to add, and now set the value of constant block around 500. And sum block you have to set plus minus for feedback. Next task will be using the feedback, negative feedback. This is about you have to connect it and submit, and this is correct. And next task. In the next task you have to open the block parameter dialog box of the discrete PED controller, where you can, here you have to set the value to select PI, and you have to set the sample time. Sample time is 0.05. And then you have to change the parameters section. Instead of proportional gain you have to use 1e minus 6 you have to set, and here you have to set 5e minus 3 you have to set. So you can just minimize, you can just adjust the size of this tab. Now to apply, just click on OK. Now you can submit. The task is correct. And next task, here you have to connect the output of the discrete controller to the local restriction block. Okay, here the local restriction block, here we have to connect via the Simulink PS converter. This is the Simulink PS converter. Via this we have connect the angular velocity measurement to the negative port of the sum block. Okay, this is the angular velocity block. This angular velocity measurement. Okay, just see this, like this you have to connect. Okay, here it is connected to the restriction block, that is local restriction block via IL with the help of Simulink to PS converter. And next we have to connect it to this negative block. Okay, next here they are given the diagnostic viewer pane will display warning when you simulate the model. You will resolve this warning in the next task. Okay, when you submit this, will be experiencing warning. Okay, view 2 warnings like this will be experiencing, but the task is completed, it shows correct only. And next task, so the warning is a task. Okay, in the next task, here you can see this. Okay, click the warning in the diagnostic viewer pane, use the command. Here you have to use this command, and the command has already been displayed. Okay, and click highlight all. Okay, just we can copy this command. Here you can view your plan, click the warning diagnostic, that is diagnostic viewer, and the command. Here we'll be having the highlight and view information about this on the suggested action. Okay, here you have to open this one, and where it will be showing highlight all, just make it as highlight all and just minimize this. Okay, just minimize this and then close this. Now add a unit block, unit delay block, and flip this unit delay block. Okay, Control I. You can, if you want to see the solution, you can see. Okay, like this you have to flip. Okay, now connect the block between the angular measurement port of the sum block to break the algebraic loop. Okay, like this you have to connect. Okay, now you delete this. You can delete this line and you can connect it here and connect this unit delay block to this sum. Like this manner you have to connect. Okay, like this manner you have to connect this. That is PS to assembly converter should be given to delay, and delay to sum you have to connect, and now you can submit. Submit, the task is correct, and the next task, and you can go to next section. Okay, no need to do the further practice, you can direct it to the next section. Okay, the next section is the project electronic value. Okay, this is the next section, the 8th section, project electronic value, where we will be having two subcategories. One is introduction, and then the second one is the project. Okay, electronic wall practice will be having. Here you can go through this overview of this category and click on next, and the task window is open. This is the last project of this course. Here you have to add, the first task is here you have to add the controlled voltage source. Okay, controlled voltage source you have to add under foundation library, and then you have to add PS constant. PS constant you have to add under foundation library. This is the PS constant, and you have to set the value of the PS constant as, that is, bring this tab, see the value 36, and here instead of 1 we have to set this as volt. Okay, now we can connect it to this control voltage source. That's it. This is task number 1. And next task, here you have to add a resistor from, once again from foundation library, and set the value of the resistor as 50 ohm. 50 ohm we have to set. And then you have to add inductor, second from foundation library, open, and you have to set the value of inductor as 1.2, 1. Okay, 1.2 e power minus 4 Henry you have to set. This first you have to set, and if you want you can connect it also. connect it like this. You can connect and submit. There is a error showing that we have to add electrical reference. You have to add. Like this. Now submit. Correct. And next task. And here you have to connect in this fashion. Here you have to add rotational electromechanical converter block under foundation library. You have to add and bring this like this, and here you have to connect in this fashion. You have to connect and bring this solver to here. You can connect it like this. You have to set the value in the rotational block, the constant of proportionality as 10. You have to set whole second per radians. Now you can submit. Task is correct. Next task. Here you have to add gearbox. You have to add, and then inertia block you have to add. Inertia block from foundation library you have to add. Control R to rotate. A gearbox you have to set the gear ratio, which is 5. By default it is 5. Whereas in inertia block you have to set the value as 0.01. Here it is mentioned as 0.001. You have to mention 0.1. You have to set the value as 0.1. Okay, and close. Now connect the rotational mechanical converter block, inertia block and gearbox, and add a mechanical reference. Okay, mechanical. Here you have to add mechanical rotational reference block. Now you can connect it here. It's a task. Now submit. Correct. And next task. And add a rotational hot stop. Okay, rotational hot stop block under foundation library. You have to add to the model and connect it to the inertia block. Okay, here you have to connect like this and set the upper band parameter. Here you have to set the upper band parameter to 360 degrees. You have to change this radians to degrees, and then here delete 0 degrees and close, then submit. Okay, once again it is having some. Here we have to add mechanical reference. Okay, mechanical rotational reference you have to add in this area. This you have to connect. Now submit. Correct. And next task. Okay, this is how the circuit will looks like. And now you have to add ideal rotational motion sensor. Ideal rotational motion sensor under foundation library. You have to add and we have to add PS to Simulink converter. Now connect the sensor to the PS to Simulink converter and rest of the model in order to measure the rotation of the ball. You can see this, like this you have to connect. Okay, carefully you can connect. This R should be connected to this inertia. You can rotate, and this R should be connected in this fashion, and this you can flip this control I. A will be coming here, and you can connect this A to this PS to Simulink converter, and in this PS to Simulink converter you have to set inherent to degree. You have to set this inherent to degree. In this PS to Simulink converter you have to set this to DEG degree. Now you can close. Degree. The circuit is same like this. Now submit. Here since error is occurring, this ID rotation sensor and mechanical rotational reference, you have to connect this C to mechanical rotation reference. We have missed this connection. Now submit, and it is correct. Next task, the 7th task, here you have to add 1D lookup table, 1-D 1-D lookup table. Here you have to use this in this manner and connect it to the angular rotation measurement. Here you can connect. Now set the value, table value as this data, table data. You have to delete, and then you can delete this and open square bracket 0 space 50 close square bracket. Here also you have to delete, open square bracket, and value 0 space 360 close square bracket. Now OK, this is the value. Now you can add a scope. Okay, scope that should be connected to this 1D block, 1D lookup table. Okay, this is the task. Now submit. The task is correct. And next task. Okay, these are next. We will be having final 2 tasks. Here we have to delete this PS constant block. Okay, this PS constant block has to be deleted. This PS1, and keep it deleted. Now we have to add this block. Okay, Simulink to PS converter block we have to add, and then constant block we have to add. Once again discrete PID controller we have to add. Once again sum block, and then unit delay block. Okay, now we have to arrange these things. Okay, first you have to use this constant block. We have to use constant block with this here. Constant block should be come here. Next one, bring this sum block. Next one, PID block, and at last we'll be having this unit delay block. Should be downward. Okay, now you can connect it like this. You can set this sum block to plus minus. You can set this as plus minus. plus minus and then OK. Now you can flip this control plus I, you can flip like this, arrange them. You have arranged and use delay to break this algebraic block. Okay, now submit. It's a correction in this block. Yes, you can check this actual layout. You have to connect. Okay, we have missed the connection. That is, we have to connect this PID block to this Simulink to PS, and you have to disconnect this. Okay, now here we have to disconnect this PID block. We can keep it as it is. We have to get supply from this output of 1D lookup table and this one to this PS constant place. Okay, and this unit delay to this sum. Now submit. The task is correct. And the next task, and the next task. Here we have to set the values. Okay, in the constant block we have to set the value as 5. Okay, and in the discrete block, this PID discrete controller, you have to set the value as PI, and then here you have to set the value as 0.1. 0.1 we have to set, and this proportional gain you have to set it as 15, and the integral gain should be 10. These are the settings. Now you can just click on OK. Just adjust this and click on OK. Now it is set. Okay, now we can submit. In that I have submitted. The task is correct. Next is task, and then next section. Okay, in the next section it is the conclusion. Okay, in this conclusion, still now what are the categories we have completed and how we can still advance the complete simulation in future. Like this, they have given some application oriented tips, and you can skip. And for additional resources, here there are some additional resources with embedded links has been given. You can use this additional resources and then click on next. At last you will be having the survey. You can fill this survey and you can complete the course. Okay, this the course is completed, and you can earn the MathWorks offered Simscape Onramp course certification. Thank you.